Hey guys, Elmer the Exponential Elephant here talking to you about scientific notation. Here's a question. Why couldn't the two elephants go swimming together? They only had one pair of trunks.
First thing we're going to talk about is scientific notation. That's a method of writing really large and really small numbers. Scientific notation is written in the form a times 10 to the nth power, where 1 is less than or equal to a, which is less than 10, and n is an integer. So when you're writing a number in scientific notation, when you're converting it into scientific notation, this number in front has to be a number that is greater than or equal to 1, but less than 10. Now, let's say your number that you're converting in scientific notation is really big, like 5 million. Well, then your n, your exponent, will be a positive integer. If you're converting a number that's really small, like really close to 0, like 0.00001, that means that your n, your exponent for 10, is going to be a negative integer. Now let's talk about how to convert to and from scientific notation. So let's say you're given a regular old number in standard form, and you want to convert that to scientific notation. You're either going to have to move the decimal to the left or to the right. Now let's say you move the decimal to the left. You have to move the decimal until you get a number that is between 1 and 10. So you keep moving your decimal until you get a number that's between 1 and 10. Now, if you have to move that decimal to the left a certain number of places, you take however many places you had to move that decimal to the left, and you add that to the exponent of 10, because you have a number times 10 to the n. So you're going to take however many decimal places you move to the left, you take that number and add it to n. If you have to move the decimal places to the right, so if you have to move your decimal to the right in order to get your number, your a, to be between 1 and 10, however many decimal places you move to the right, you're going to subtract that number from the exponent of 10. Next, we're going to talk about converting the other way. So if you're given a number in scientific notation and you're going to convert it to standard form, there's two things that you have to look out for, okay? If you have a positive exponent, what you're going to do is you're going to take the decimal and you're going to move it that many places to the right. So whatever your exponent is, if it's positive, you take the decimal and move it that many places to the right, whatever your exponent was. If your exponent is negative, you take your decimal and you move it that many places to the left. Now, we'll do a bunch of these so you start getting familiar with where to move it and how many places to move it and all that.
What was the elephant doing on the freeway? About 5 miles per hour. Example time.
Now, example 1 says write the following numbers in scientific notation. So let's go ahead and do that. Here, we are converting from standard form, regular number form, into scientific notation. What we need to do is locate the decimal. Where is the decimal in this case? Well, there is no decimal. But technically, if there is no decimal, your decimal is at the end of the number. So here is our decimal right here. Now, we need to move the decimal in order to get a number between 1 and 10. So we're going to take this decimal and we're going to keep moving it to the left until we get a number that is between 1 and 10. 34, no, 3.4. There you go. 3.4 is a number between 1 and 10, so we can stop. Now the question is, how many decimal places did we move and which direction? So we moved 1, 2, 3, 4, 5 decimal places to the left. Now, we moved 5 decimal places to the left, which means we're going to take however many decimal places we move, we're going to take that number and add it to the exponent of 10. So 3.4 is going to be our a value, the number out front, and it's going to be times 10 to the, and we moved 5 places, so 10 to the 5th. And that's how you do it. Let's try it again. So here we have 0.002. So 0.002, what we're going to do is we're going to take our decimal and we're going to move it until we get a number that is between 1 and 10. So I take this decimal and I'm going to move it to the right this time, right? I can't move it to the left because that would get us farther and farther away from a number between 1 and 10. So I'm going to move it to the right. So I'll move it 1 place, 2 place, 3 places. Boom. That will give us 2. Since we now have a number between 1 and 10, we can stop and we can say 2 times 10 to the what power? Well, I moved 1, 2, 3 places, and I moved to the right. Since I had to move to the right, I'm going to subtract that from our exponent. So it's going to be 2 times 10 to the negative third power. Try it again. So we have 54,300. Again, there is no decimal, which means our decimal is at the end of the number. So I'm going to take that decimal, and I'm going to move it to the left. So how many places do I have to move until I get a number between 1 and 10? 1, 2, 3, 4. There you go. 5.43. That is a number between 1 and 10, so I can stop. How many places did I move? 1, 2, 3, 4. And did I move to the right or left? I moved to the left, which means I'm going to add that number to the exponent of 10. So it's going to be 5.43 times 10 to the fourth power because I moved over to the left 4 places. Try it again. 2 is a number that is already between 1 and 10, which means if I wanted to write this in scientific notation, it would be 2 times 10 to the, and I didn't move to the left or right any decimal places. So it would be to the 0 power. And this makes sense, right? Because 10 to the 0 power is 1. So 2.0 times 1 is just 2. And that's how you get that.
What's big and gray and hates Sleeping Beauty? Malevolent. You try.
Okay, so here we're doing the same thing. We're converting from standard form to scientific notation. Here we have our number 452,000. We're going to start, where's our decimal place? Well, there is no decimal, so it's at the end. And we need to move it until we get a number that is between 1 and 10. So we start here and we move our decimal place over until we get a number that's between 1 and 10. Done. 4.52. Now, how many places did I move? 1, 2, 3, 4, 5. And I moved to the left, which means I'm going to add 5 to our exponent of 10, which means it's going to be 4.52 times 10 to the 5th power. Here, I'm going to take this decimal and move it to the right. 1, 2, 3, 4, 5, 6 places until I get a number that's between 1 and 10. 3 is between 1 and 10, so I can stop. So it's going to be 3 times 10 to the what? Well, I moved to the right 1, 2, 3, 4, 5, 6 places. So since I moved to the right, I subtract that from our exponent. So it's going to be 3 times 10 to the negative 6th power. Here, I take 312 million, and I need to find my decimal. It's at the end. Since there is no decimal, it's at the end of the number. And I'm going to move it to the left 1, 2, 3, 4, 5, 6, 7, 8 places until I get a number that's between 1 and 10, 3.12. So 3.12 times 10 to the what? Well, I moved to the left 1, 2, 3, 4, 5, 6, 7, 8 places. So it would be 3.12 times 10 to the 8th power because I moved to the left. So my exponent is going to be positive. 0.5. All I have to do is just move the decimal until I get a number that's between 1 and 10. Do I move to the left or right? Well, if I move to the left, I get farther away from a number between 1 and 10. If I move to the right, I get 5, right? So I'm going to move 1 place to the right and I get 5 because that's between 1 and 10. So now I take 5 and it's going to be times 10 to the what? Well, I move to the right 1 decimal place. And since I move to the right, that's going to be a negative exponent. So I get 5 times 10 to the negative 1st power. Example 2, we're going to do the opposite this time. We're going to go from scientific notation and put it into standard form. Now remember, going from scientific notation to standard form, this should be the easy one. If you have a positive exponent, what you're going to do is you're going to take the decimal and you're going to move it that many places to the right. If your exponent is negative, you take your decimal and you move it that many places to the left. So since it's 1.0 times 10 to the positive 5th, I take the decimal and I move it to the right 5 decimal places. And you're done. Here, it's 5.38 times 10 to the negative 4th. Since it's a negative exponent, I'm going to move the decimal place to the left that many times. So negative 4, I move the decimal to the left 4 decimal places. 1, 2, 3, 4. Now, again, any decimal place that you skip where there isn't a number, you're going to put in a 0. So in this case, it would be 0.000538 since I moved the decimal place over 4 times. Here, 6.11 times 10 to the 1st. I'm going to move the decimal place to the right since it's a positive exponent 1 time. So I move it to the right 1 time. So I get 61.1. Now 5.001 times 10 to the 0 power. Since it's to the 0 power, it's neither positive nor negative. So I don't move the decimal place. I leave it as 5.001 and that is my answer.
What did Tarzan say when he saw a herd of elephants? Look! A herd of elephants! You try.
Okay, again, converting from scientific notation to standard form. I'm going to take the decimal and move it depending on whether the exponent is positive or negative. So here, my decimal, since I don't see it, it's right at the end of this number right here. I have a positive 2 as my exponent of 10, which means I'm going to move to the right. And how many places do I move to the right? 2 places. So it would be 1, 2. Again, any place that you move where there isn't a number, you're going to add a 0. So it's going to be 500. That would be 500. Here, 7.2 times 10 to the 4th. I'm going to take this decimal and I'm going to move it. Since it's a positive exponent, I move to the right. So I'm going to go 1, 2, 3. And any place I move where there isn't a number, I put a 0. So it's going to be 72,000. Here, 2.74 times 10 to the negative fifth. It's a negative exponent, which means I'm going to move my decimal place to the left. So I take my decimal and I go 1, 2, 3, 4, 5 places to the left, and I end up getting 0.0000274. Lastly, I have 1.3 times 10 to the 0. Again, 10 to the 0 is 1, and 1 times 1.3 is just 1.3. Or you can think about it, we're not moving the decimal place because our exponent is 0. So you just leave it as 1.3. Now, multiplying in scientific notation. When multiplying a number in scientific notation by a constant, we're going to take our number, our constant that's out front, and we're just going to multiply it to that first number, our a value, whatever that is. So you end up getting m times a times 10 to the nth power. So you just take whatever that number is and multiply it to the number that is in front with the scientific notation, your a value. Now, the tricky part is if you multiply this, m times a, and you end up getting a number that is bigger than 10 or less than 1. What you have to do is you have to convert it back into scientific notation. So if m times a is not between 1 or 10, then you must change your n. So you're going to move the decimal and either add or subtract to your given n value. Example 3 says multiply. Leave your answers in scientific notation. So here we're going to take 4 and we're going to multiply it to 1.0 times 10 to the fifth. So all we have to do is take 4 and multiply it to 1.0. What's 4 times 1? That's 4. So our answer now is going to be 4.0 times 10 to the fifth. Let's try it again. So here we have 3 times 5.1 times 10 to the negative 4. So what I do is I distribute this 3 to the 5.1. Again, you don't have to multiply it to the 10. Just take the 3 and multiply it to the 5.1. That's all you have to do. So 3 times 5.1 is actually going to be 15.3. The tricky part here is 15.3 is no longer between 1 and 10. So what we have to do is move the decimal to convert it so that it is between 1 and 10. Well, I'm going to move it to the left 1 place. The reason I do that is I get now 1.53. That's a number between 1 and 10. So it's going to be 1.53, but since I moved the decimal place to the left, I add that number of places that I moved to the exponent. So I moved 1 place, so I add 1 to my exponent of 10. So this becomes 1.53 times 10 to the, what's negative 4 plus 1? That's negative 3. Here we have 10 times 6.11 times 10 to the first. Again, we're just multiplying the 10 to the 6.11. That's it. 10 times 6.11 or 6.11, you end up getting 61.1 times 10 to the first. Again, we have a number. Our a value up front is no longer between 1 and 10. So we have to convert it back into a number that is between 1 and 10. So how do I do that? I move 1 decimal place to the left. That gives me 6.11. Again, that is now a number that's between 1 and 10. Because I moved 1 decimal place to the left, I have to add 1 to my exponent over here, and I end up getting 6.11 times 10 to the second power. Lastly, 0.2 times 3.21 times 10 to the negative first. So I take this 0.2 multiplied to the 3.21, and I end up getting 0.642 times 10 to the negative first. Now again, this number out front is not between 1 and 10, so I have to convert it so that it is between 1 and 10. So I take this decimal and I move it to the right 1 decimal place. Now because I moved it to the right 1 decimal place, I have to take 1 and subtract it from this exponent. Now what's negative 1 minus 1? That's negative 2. So my answer now is going to be 6.42 times 10 to the negative second power.
What do you call an elephant covered in mud? Dirty! You try.
Okay, we'll start with A. So we take 2, multiply it to the 3.0, we get 6.0 times 10 to the third. In part B, we have 40 times 3.0. Now, what's 40 times 3? That's 120. Now, 120, that's not like the 6 up here. 6 was between 1 and 10, so we got to leave it just like that. 120, we now have to convert it so that it is a number between 1 and 10. So I'm going to take this decimal and move it to the left 2 decimal places. Now, since I had to move it to the left 2 decimal places, I have to add 2 to my exponent here. And what's negative 2 plus 2? That's going to be 0. So this is going to be 1.2 times 10 to the 0 power. Here, 12 times 4.2, I distribute that and I end up getting 50.4. Now this number is not between 1 and 10, so I have to convert it so it is. So I take this decimal and move it to the left 1 decimal place. Because I moved 1 decimal place to the left, I have to add 1 to my exponent over here. What is 3 plus 1? That's 4. So I get 5.04 times 10 to the 4th power. Lastly, I take 0.5 and multiply it to 5.002, and I end up getting 2.501 times 10 to the 0. Because this number is between 1 and 10, I can just leave it like this. Now, our word problem says in 2010, the population of the United States was about 3.09 times 10 to the 8. Spending for healthcare will be about $8,754 per person. About how much will the United States spend on healthcare in 2010? Use scientific notation. So, in a word problem, we're not scared. That's step one. Step two, we're going to define our variables. What is the question asking? About how much will the United States spend on healthcare in 2010? So we're trying to figure out how much money. So we'll say M. M is the money the US will spend on healthcare in 2010. So what we do is we now have our variable. So we are going to write our equation. How much money are they going to spend? Well, it's $8,754 per person, but the total population of the United States is 3.09 times 10 to the 8. So we're going to take that population and that cost per person, and we're going to multiply those together, and that'll give us the amount of money the United States will spend on healthcare. So we take the amount per person and multiply it to the population. Now, how do we multiply these two numbers together? Well, we just learned how to do that. We take the 8,754 and multiply it to the 3.09, and we end up getting 27,049.86. Now, we want our final answer to be in scientific notation. That's what it says right here. So let's convert this so that it's still in scientific notation. Remember, this number out front has to be between 1 and 10. So we take our decimal and we're going to have to move it to the left 1, 2, 3, 4 decimal places. That gives us 2.70496. That'll be a number between 1 and 10. So because we moved our decimal place to the left 1, 2, 3, 4 decimal places, we have to add 4 to our exponent here. And that gets us 2.70496 times 10 to the 12th power. Now you could write this as your answer, but what we normally do in scientific notation is we round to the 100th place. So I'm going to say for my answer here, since we were asked a question, we need to answer in a sentence. So about how much will the United States spend on healthcare in 2010? The United States will spend approximately 2.70 times 10 to the 12th dollars on healthcare in 2010.